All right, so finishing part C of August 2017, number 37, everybody. He's got a $3,000 deductible. How many years is it going to take for that to get out of the car? Can you please go back to the beginning of the problem, everybody? It gave you two equations go back to the beginning of the problem. It gave you two equations. Can you figure out which one is for the value of the car, please? Find that equation that represents the value of the car, because that's what I need from. You got a V equation and you got a Z equation. Everyone see which one is for the value of the car? Go ahead, write it down in part C. Help me now. Let's go. Let's start chanting, yelling some stuff out here. Which one is the value of the car? 28,482.698 times 0.684 to the T. That was the value of the car equation. Equals deductible. What's the deductible amount? When does this equal 3,000? Geez, how many of these have we solved? Right? When is the deductible 3,000 equal to the value of the car, V of T? All right, I'm going to turn it over to you guys. Where are we going? Divide both sides by the number out in front. 28,482.698. Divide both sides. So on the right side, I'm left with 0.684 to the T. And hopefully, what are you not doing to this number right now on the left side? Hopefully, you're writing it all out. Do not round it. I'm getting 0.1053271007. I do not like it when the exponent is variable. I like to bring it down, but if I decide to bring it down, what's the rule? Log, not just the number it's with, but the other side as well. And then the solve for T. Divide both sides by the log of 0.684 and look at the rounding directions. And we're getting about 6 years, hopefully. All seriousness, anybody want to see how, in case you're not a big fan of doing this log stuff, how we could have used the calculator to do this? Okay, you got this V of T, right? So I could have, I'll just show you up here on mine. I could have graphed that, and I want to know when it's equal to what? 3,000. Graph both of them. So there's the V of T. Here comes 3,000, I think. Or not. Is that because I need to change my window? Yeah, because see, I was going from 4,000, so I better adjust that, huh? Okay, what, 2,000? There's the value, 2,000. Okay, and then I might want to make it higher up, I guess, or more X values, it looks like. All right. But again, and then where can I go on my calculator once I see where they intersect? Intersect, right? Second trace, intersect, and I can see it. Okay, again, if you do it that way, what do you have to write down? I went there, I went on the graphing calculator, went to second trace, intersect again. Okay, but that is you don't have to do it algebraically. It doesn't say algebraically, so all right, you can do it that way. Okay. All good? Anything else there? All right, we're done with this. You can put this bad boy away to whenever you start your hardcore reviewing. And we're going to go to June 2017 now. June 2017. Do a couple multiple choices with you. June 2017, number 13. In June 2017, number 13. Okay, everyone go ahead, go. Read through it for me. Read through it. Seems very confusing as you read through it and finish it. But remember, a lot of these multiple choices, I can do one of two things. I can plug in the answers, or I can store in my own number, which is the case here. Okay, because I'm looking which two equations are equal to each other. All right, first thing you got to identify though, guys, what's the D value mean? That's decades. And then when you go down and look at your multiple choices, you have Y there. And what's Y? Years. Okay, so let's be careful here. So anybody want to store a random number in for D now? Because we're all going to do it the same way here today. What random number do you want to store in for D? 8? I don't care. Don't make it a huge number though. 8, okay. So everyone go ahead right now, store in 8 for D, and find that value of the equation in the problem. And leave it in your calculator. Leave that on the top line of your calculator. Okay, leave it in the top line of your calculator. Okay, now I want to figure out which equation's the same as that one in the multiple choices. But here's the thing though. When you plug in for Y, you're not going to plug in for 8. You're not plugging in 8. What did D mean again? Decades, and Y was years. So if we're going to do it this way, we need to know how many years are in a decade. It is 10, yes. So if I plugged in 8 decades, how many years do I need to now plug in? 80, yes, 8 times 10. So now go through all the multiple choices, plug in 80 for Y, and find out which one is going to come the closest to the original. Guys, it will not be exact, but it will be pretty darn close versus the other 3 you try. All right, so go right ahead. I'll give you guys a couple minutes. Store in 80 now for Y and figure out which one comes the closest to when you plugged in 8 for D. It's not going to be equal, but it's going to come pretty darn close and a lot closer than the other 3 multiple choices. Anybody finding which one comes pretty darn close? Yep, 3 comes the closest. Yep. So again, I just want to remind you guys, you can plug in your own numbers to see which equations are equal, but just be careful here. Got a little tricky because it wasn't the same number you plugged in for both variables. All right, so just be careful. Anything you want to ask there? Go right below, number 14. I want to just refresh your memory on how to test if two things are independent or not. So read about Gary, Jane, and their child. All right. All right. Thank you very much. Appreciate it. You guys have a good night. High five. There you go. Good job, guys. Thank you. Appreciate it. Review quizzes for tomorrow just arrived. Look at those bad boys. There they are. Fractions, number 1. Exponent rules. Well, I had to fit 19 of them on here. Which equation represents an even function? Remember that one? Who knows? Which equation represents an even function? Better look back at that, huh? All right, here you go. Ready? All right, here we go. Are they independent or not? So if they are independent, anybody remember what test you have to do here? Nope. Nope, 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 nope. Come on, come on. Multiply the two separately. So everyone ready? Blue eyes. What's blue eyes? So does 0.25 times blonde hair, 0.5, you are testing to see if is that equal to both of them together, which is what probability for us? 0.125. So that's on you right now. Both of them multiplied equal the and. Probability of A times B equals A and B. And what are you guys finding out? Okay, they are equal, which means they are independent, but we got this little sneaker here, mutually exclusive. Ooh, yikes. Here's what mutually exclusive means. They cannot, if two events are mutually exclusive, they cannot happen at the same time. Blue eyes, blonde hair. Can they happen at the same time? Yes. So are these mutually exclusive? No. All right, because mutually exclusive means, hey, they don't happen at the same time. I can have a kid with blue eyes, blonde hair. All right, that can happen. So they are not mutually exclusive. The only thing they are independent. What's the deal? That's what I thought. All right. I was trying to think because both my girls have blonde hair. I have no idea what their eye color is. Does that make me a bad dad? I have no idea. I would be guessing. Total guessing. No idea. Green? I don't know. Sure. Okay. Maybe brown. Maybe a little gray here. I don't know. I can't really tell. Not too sure. Yeah, maybe. You know, this was taken, I think, in May or April last year. I don't even know. Okay. All good there. All set? 21. Now that I think about it, Mrs. Carlingham, no idea either. No idea. No idea. Yeah. We just stare at each other. No idea. We avoid eye contact in the Carlino house. Yeah, yeah, it was awkward, huh? It was awkward. Yep. All right, here we go. Next one. Rate of change. There it is. Average rate of change. Anybody got the formula? What goes on top? Yep, your Y values will go on top. On the bottom, X values. And I've told you, they'll usually give you the X values, which they do again. What are the X values that go on the bottom? -7 and 7. All right, so we'll go 7 minus -7. So you should have 14 on the bottom. Guys, where do I get those Y values now? In the equation they give me. So first thing, store 7 in. But whoa! It's a sine one. Make sure your calculator's what? If you're going to plug into a sine or cosine. Radian mode. Make sure it's radian mode, which it should be. How do you check? You hit your mode button. And radian should be highlighted. So everybody store 7 in for X. Let's find the value when you store 7 in. You should be getting a negative decimal. You know you're on the right track. Okay, just to make sure you're on the right track. When you plug in 7, you guys get a negative 0.2973017788. Everyone's good so far. Okay, now store in -7 and copy and paste that equation again. I wish there was a way I could cast individual graphing calculator screen up here. So we see what everybody's doing. Like you can cast your Chromebook screen up here. I wish I could do it for the calculators. So I could see if you're doing it correctly or even doing it at all. And who even knows what a fraction template is yet? 20 weeks into the school year. I know Mike does. Okay, now you're minus point. Are you getting 3? Oh, not point, sorry. 3.3, 63, 585, 661. There you go. Okay, now it's all figuring out what you're to the nearest hundredth, what the average rate of change is. Then what do we add? Choice. Yep, negative 0.26. Any questions there? Okay, before I get to the next, do not hate. Be extremely happy next Thursday if this is one of the questions. All right, because that doesn't, this is one of the easier questions. All right, so you're going to look at it and be like, I hated these. They take so long, but be very, very lucky if we get this. Number 33. 3 variables, 3 equations. Be very lucky. Trust me, it could be a heck of a lot worse. Be very lucky. All right, here we go. First step, pick 2 equations. Let's eliminate a variable as a class. 1 and 3, eliminate x, I'm assuming. Okay, you guys got it. X plus y plus z equals 1. Negative x plus 3y minus 5z equals 11. All right, help me. X's are gone. I get it. What about how many y's are left? That's what I was thinking. Positive y plus 3y. 4y. Everyone all right? Or are you just getting after it? What about the z's? Minus 4z equals okay. Okay. It's really getting long. We've done this too many times. Equals 12. All right. Now, if you've decided to eliminate x, pick another 2 equations and eliminate x. So you got to pick 2 with another one. Which other equation along with equation 2? 1 or 3? Okay, 3 it is. You can do it both ways. Okay. What are you going to multiply the second? What are you going to multiply this first one or the third one? Whatever. This one you picked. Yeah, you got to multiply it by 2. Do you guys like these or no? The only thing I'll warn you about, when you multiply by a number, make sure that number gets multiplied on the other side of the equal sign. I always see some people forget to do that. And I forgot to do something. Calm down. I got it. Got everything else look good? 22. Okay, we're good. All right. X's are gone. What's my new equation? How many y's now? 10 y's. And with the z's, minus 4z and my number 24. All right. Those two now take to put together and figure out another variable to eliminate. Okay, they can't. I know people are going for the z's, which I respect, but they don't eliminate each other right away. I'll multiply the second one we did by -1. Is that all right? So I get negative 10y plus 4z equals negative 24. What? I multiplied this one by -1. Yes, you could multiply that one by -1 as well if you wanted to. What's your deal? Good talk. That helps me out a lot. We all right? You can multiply this one by -1 if you want. I just chose to multiply the second one by -1. All right, what do you get with the y's? I have negative 6y. Some of you guys might have positive 6y, depending on which one you multiplied by -1. Regardless, how many of you get so happy at this point right now? Because you know you're not going to get a decimal. And you must have done something right. That is the best feeling when it comes to these. Now, is it the right whole number? I don't know, but who cares, right? I got a whole number. Y equals 2. All right. What can I do now to find another variable? Yep, plug y into any of these original ones, right? Thoughts? You got it. So 4 times 2 minus 4z equals 12. 8 minus 4z equals 12. Let's see, negative 4z. Oh, look at that. Again, it's going to happen. Z equals negative 1. And how do I find x? Where do I have to go now? All the way back to one of the first 3. Let me guess which one you're going to pick. Yeah, the first one. x plus y plus z equals 1. Try to show off. They're like, I got my 26 points. I'm just showing off now. That's what a kid tried to tell me 5th period today. He's only going to answer the first 13 multiple choice and get up and walk out and leave. That's how confident he's going to be. I said, good luck with that. Yeah, good. Freaking Ferris. Yeah. Yeah. He's like, what if I just answer the first 13 and just head out? Hey, don't come second semester, I can tell you that. All right, never mind. I have nothing to say about that one. You just want to answer the first 13. And then when the cutoff is 28 instead of 26. That'd be awesome. He does get the first 13 right, but the cutoff's 28, not 26. That stinks. X equals. I've said this a few times. You have to be there for 2 hours. Let's say you've been staring at the drums and the cymbals in the band room and fighting the urge to go up and start banging on them. You've been to the bathroom 5 times, and you still have 45 minutes left. Might be a good idea to check them once in a while, okay? You're not going to reject anything, but you got 45 minutes left, and you've been to the bathroom 5 times, check them. And just a little note, if you do check them, it does have to work in all 3. If it works in one of them, congratulations. It's got to work in all 3, though, for it to be a true solution. Whew, all right, all good? One more to go. And thank your lucky star. You may not think this right now, but thank your lucky stars if we get this one too. 36 with stats. And let's be real, the only reason you don't like it is that it's a lot of words. It's a lot of words. No, not at all. It's set on random. All right, ready? You can read about Charlie's Automotive right now. Yep. If you assume the set of data approximately is a normal and dealership wants a 95% confidence, find that interval. Find that interval. So 95% confidence interval. Okay, how do I find it? What's the formula to find it? Mean plus or minus your margin of error. Where do I get the mean from in this case? It's on the dot plot. 0.506. So 0.506 plus or minus. Ooh, margin of error. How do I find that? That's not on the dot plot. That's the other one. Dig deep. Plus or minus 2 times standard deviation, yes. Where's the standard deviation located? On the dot plot. And what's that one there? 0.078. So 2 times 0.078. And that'll be plus or minus 0.156. Okay, so 0.156. Now all you guys have to do is add the 2 and subtract the 2 and round, round to where it asks for. What's your 95% confidence interval? 0.35 through 0.66, nearest hundredth. And if you're going to have to find it, you're going to have to do something with it, which comes to the last part, part C. 40 customers selected at random, and they find out the proportion of customers who prefer is 32.5%, and they decide not to implement it. Why not? Well, 32.5%. What's that as a decimal? Point. And look at that interval you just did. Tell me where 0.325 falls. Yeah, outside. That's why they're not going to do it. All right, because 0.325 falls outside the 95% confidence interval. I got a bonus question. Ready? The 32.5%. Is it statistically significant if it falls outside? I'm getting some yeses and some nos here. If it falls outside, is it statistically significant? Yes. Yes. Two ways we can refer to it. We can refer to it as unusual or statistically significant. And because I want to prepare you for everything, is there another way we could have determined that without using the confidence interval? Let's say we weren't required to do the confidence interval. Is there a way we could have used the dot plot to figure out it was unusual? All right, ready? 0.325. See where it fell? 0.325 right here. How many are at or below? 1 out of what? How many times did I do this? 100, which is what? 0.01? Help? No, I don't know. Is it 1 divided by 100? 0.01. So 1%. What's our cutoff to be significant? 2.5. So it's unusual because it falls outside the 2.5%. All right. All right. Same thing I did for fifth period. I put you through a lot the last couple days so that you have the rest of the time to yourself. Okay, I'm not going to have you do extra questions. Tomorrow you got your review quiz. Thursday, Friday, it's a review sessions, all right, on your own stuff.
So